Welcome back, everyone. This is the second discussion video for Chapter 10, and it starts here with Learning Objective 2, which is to compute the direct labor rate and efficiency variances and explain their significance. The nice thing about our labor and overhead variances here are that they're very, very similar, at least in terms of how we calculate them, to our materials variances, the price and quantity variances from last time. So let's continue with this Glacier Peak example. Remember, they were making some mountain parkas here. They've got a standard for labor. It should take 1.2 hours per parka in direct labor, and the labor wage rate is $10 per hour. Last month, employees actually worked 2,500 hours at a total labor cost of $26,250 to make 2,000 parkas or jackets. So I'm going to lay that out in our nice little three-column approach here. Again, on the far right is our flex budget equivalent, the standard hours and the standard rate. In the middle, we have what I referred to as that as-if budget, the actual usage, so the actual hours, but by the standard rate. And in the far left is, reality, what really happened, the actual hours and the actual rate. So starting back with those standards, we had a total of 2,400 direct labor hours by standard. That's the 1.2 hours per jacket times the 2,000 jackets we made. So 2,400 hours times that standard rate of $10 for a total cost of $24,000. On the far left for our actuals, we were told that total direct labor cost was $26,250. If we wanted, we could divide that by the 2,500 actual hours worked to get an average rate of $10.50 per hour. And then, of course, in the middle, our as-if budget, we're taking the actual hours, the 2,500 hours that were really worked, but multiply now by the standard rate, the $10 per hour, for a total of $25,000. Now, this time I'm going to point out a couple things before we talk about the variances specifically. Note that if we look at the actual rate paid in terms of direct labor, $10.50 per hour, versus that standard rate of $10, before we look at that bottom line, we know that we're going to have an unfavorable labor rate variance. We paid more per hour than the standard said we should have. So we'd be looking for this unfavorable rate variance. Similarly, over here, we know that the standard calls for usage of 2,400 hours. We actually use 2,500 hours, so we should be looking for an unfavorable efficiency variance as well. Now let's quantify those here. If we compare the flex budget equivalent, $24,000, to the as-if budget total, $25,000, we've got a difference of $1,000. Again, the as-if is greater than the flex equivalent, so yes, that is an unfavorable efficiency variance, or usage, right? We're talking about usage of this labor. On the left-hand side, we've got the actual result of $26,250 versus the as-if total of $25,000. So our difference there of $1,250 is an unfavorable rate variance. Again, we're paying more per hour of labor than the standard says we should be. Also worth pointing out here that these two lower level variances, the rate and efficiency variance, will net out for our spending variance. In this case, we've got a $1,250 unfavorable rate variance, a $1,000 unfavorable efficiency variance. So add them together, we've got a $2,250 unfavorable spending variance for labor. And thinking back to Chapter 9, that would come from comparing directly the actual result, $26,250, to that flex budget equivalent, $24,000. $26,250 minus $24,000, there's our $2,250 unfavorable spending variance. Now we can also find these things with those factored equations. Our rate variance, we're again looking for the difference in the rates, or the R's. So we need our actual hours times the difference in those R's. Actual rate minus the standard rate. Here that's the 2,500 actual hours times the difference between the $10.50 actual rate per hour and the $10 standard rate per hour. 2,500 times 50 cents, there's our $1,250 unfavorable rate variance. Efficiency variance, we're comparing the difference in the hours there, the usage, and then multiplying by that standard rate. So standard rate of $10 per hour times the 2,500 actual hours minus the 2,400 standard hours gives us $10 times 100 hours, or $1,000 unfavorable efficiency variance. And again, if you don't like the factored equations, don't use them. You can still use that overall 3-column approach, because that's essentially what we do with the factored equations. We just turn the budget, if you will, into the R's and the H's here. Let's try another one for practice before we go on then. So Zany Electronics uses a standard cost system for production of its water ski radios. The direct labor standard for each radio is 0.9 hours. The standard direct labor cost per hour is $7.20. During the month of August, Zany's water ski radio production used 6,600 direct labor hours at a total direct labor cost of $48,708. This resulted in production of 6,900 water ski radios for August. What is Zany's labor rate variance for August? So pause this, work through that, and then come back here for the solution. So that would be D, $1,188 unfavorable rate variance. So this would come from comparing the differences in the R's, or isolating, if you will, kind of that actual result, the actual hours and the actual rate, and the as-if budget in the middle, the actual hours and the standard rate. So here we knew the actual spend in total was $48,708. We also knew that the actual hours was 6,600, because it said during the month of August their production used 6,600 direct labor hours, right? And we know that standard rate was $7.20. So now I've got everything I need. I do the math out there and I get 48,708 minus the 6,600 times 720, or 47,520, and there's my difference, 1,188. Again, this is unfavorable because I spent more than the standard said I should have. One more here. The FIME Corp uses a standard costing system. The following data has been assembled for December. We had actual labor hours worked of 6,200. The standard direct labor rate was $7 per hour. The labor efficiency variance was 2,100 unfavorable. Given that, the standard labor hours allowed for December output must have been what? So pause this here, work through that, and then come back for the solution. So that would be A, 5,900. So we know that efficiency variance, which is 2,100 unfavorable, comes from the differences between the usage, the H's, the hours, right? Multiplied by that standard rate. So we knew the actual hours were 6,200. We don't know the standard hours, and we do know the standard rate, $7. So the $2,100 unfavorable variance would be equal to the difference between the 6,200 actual hours and the standard hours, whatever those are, times that $7 standard rate. So we'll back solve here for the standard hours, the one missing piece, and we get our 5,900 there. Let's talk a little bit about responsibility as we did with materials. Production managers are usually held accountable for labor variances because they influence a whole bunch of factors that should relate to how labor is used or what it costs. They determine the mix of skill levels assigned to work tasks, right? They're making schedules, getting different people assigned to different roles within that production process. They certainly have a significant influence on the level of employee motivation. Those of you that have worked either part-time or full-time before, you may have had, good managers and bad managers, or somewhere in between. Those certainly affect employees' motivation, their willingness to put forth maximum effort, and so on. So that would be another factor that might affect these variances. Now, relatedly, we would say that production managers affect just the overall quality of production supervision. Are they keeping people on task as needed? Are they letting people work autonomously and not micromanaging? All these things kind of go hand in hand. And then finally, they're responsible to provide training to employees. So we can certainly end up with labor variances if we have poorly trained employees. The production manager would be our first line of contact there. Do people know how to do their jobs properly? Just like we talked about with our materials variances, labor variances are not always entirely controllable by one person or one area. Just as an example, the maintenance department manager might do a poor job of maintaining production equipment. Stuff might be broken down all the time. That could increase the processing time required per unit, We could have people standing around waiting to be able to use machinery and things like that, and that might lead to unfavorable efficiency variances. On the other hand, the purchasing manager might purchase lower quality raw materials than we should be purchasing. That could lead to an unfavorable efficiency variance for labor as well if people are having to rework things or redo things along the production line because of the poor quality material or having to throw out additional material. That brings us to our learning objective 3 here, compute the variable manufacturing overhead rate and efficiency variances and explain their significance. And these things will look and feel very similar to those labor variances. So let's continue with our Glacier Peak example, and let's say they use direct labor hours as the allocation base in their predetermined overhead rate. So the company has the following standard variable overhead cost for each jacket: 1.2 standard labor hours per jacket. We already talked about that with our labor standard. And for a variable overhead rate, the standard is $4 per labor hour. Now, last month, employees actually worked 2,500 labor hours to make 2,000 parkas, as we discussed. And let's assume that actual variable overhead for the month was $10,500. To come up with our rate and efficiency variances, we'll again lay out our 3-column approach here. On the far right, we've got that flex budget equivalent, all of our standards, our standard hours and our standard rate. Standard hours was the 2,400, the 1.2 hours per jacket times the 2,000 jackets. That standard rate was $4 per hour, so that total should be $9,600. Over on the far left, we've got our actuals, and that's the actual hours, 2,500 labor hours, times the actual manufacturing overhead rate. We didn't know this, but we were given a total here for a spend on that variable overhead of $10,500. So really we're backing into that rate by taking the $10,500 total divided by the actual hours of 2,500 for a $4.20 per hour actual rate. So now we can get our variances here, comparing the as-if budget in the middle, and then finally we had our as-if budget in the middle. The actual hours of 2,500 times that standard rate of $4 per hour for a total of $10,000. And now we can get our variances. On the right, we've got our efficiency variance, where we're all about usage differences. $10,000 in the as-if minus $9,600 in the flex equivalent is a difference of $400. And in this case, the as-if is greater than the flex equivalent. So that's an unfavorable efficiency variance. Again, look at your usage. Actual hours 2,500, standard said it should have been 2,400, so yeah, we should have an unfavorable efficiency variance. And then on the left, 10,500 was our actual spend. The as-if said 10,000, so we've got a $500 unfavorable rate variance because actual was greater than the as-if. And one more time, just look at your inputs, got to double check your direction of favorability. The actual rate for overhead was $4.20 per hour. Standard says it should be $4, so yeah, that's higher. We should have an unfavorable rate variance. And again, we can use those factored equations if we prefer. For the rate variance, we're talking about to get the difference in the R's or the rates. So we've got our actual hours times the actual rate minus the standard rate, 2,500 actual hours, times the difference between the $4.20 actual rate and the $4 standard rate, and there's our $500 unfavorable rate variance. For efficiency, we're looking for the differences in the H's, the usage, the hours. So we've got our standard rate times the actual hours minus the standard hours. That's $4 standard rate times the difference between the 2,500 actual hours and the 2,400 standard hours. There's our $400 unfavorable efficiency variance. Now, one other thing, a caveat to be aware of here, the quantity variance for materials is calculated only on the quantity used. The price variance, though, is calculated on the entire quantity purchased, and sometimes the timing of those isn't in the same period. We may buy materials and not use them till later. So if we have that case, we can actually extend our variance analysis to isolate the price and quantity variances kind of at the same time a bit better. So let's go back to our Glacier example and let's change just a couple little pieces here. let's say they still had the direct materials standard of 0.1 kilograms of fiber fill per parka at $5 per kilogram. But let's say last month 210 kilograms of fiber fill were purchased at a cost of $1,029, but we only used 200 of those 210 kilograms to make the 2,000 jackets that were produced. If that's the case, we'll extend this to a 4-column approach. I know it starts to get a lot of things on one page here, but now we've got still the flex budget equivalent on the far right, standard quantity and the standard price. Now next to that, we're going to have the actual quantity used by the standard price. To the side of that, we'll have the actual quantity purchased by the standard price, so that on the far left, we can have actual quantity purchased times actual price. Okay, so now we've got essentially two as-if budgets in the middle here. One's got the actual quantity used in the standard price. The other's got the actual quantity purchased in the standard price. That way we can better disentangle this price variance on everything we've purchased from the quantity variance on everything we've used. So let's fill out kind of the numbers here for this example. The flex budget equivalent, the standard quantity is the 200 kilograms used for the jackets times the $5 per kilogram that it should cost, or $1,000. Now we're saying the actual quantity used was only the 200 kilograms, what it should have been in other words, times that standard price of $5. So now we don't have any quantity variance. No difference driven by a difference in usage. Should be using 200 kilograms for 2,000 jackets, and that's what we did use. Now over on this side, we're looking at just the quantity purchased for everything. Okay, 210 kilograms. So now the as-if for that says 210 kilograms, the actual quantity, times the standard price of $5 is $1,050 in total. The actual result, the actual quantity purchased times the actual price, 210 kilograms times $4.90 per kilogram, was the $1,029 total spend. So now the price variance is the difference between those two. It's calculated on the total purchased $1,029 minus $1,050, and there's our $21 favorable price variance here. Okay, in other words, stemming from the $4.90 we paid per kilogram when the standard said we should have been paying $5. So just one other little kind of wrinkle there that we can have. Now let's wrap up talking about some potential advantages or problems or issues with standard cost. From the advantage standpoint, standard costs are a key element of management by exception. Management by exception is really just a fancy way for us to say, looking for exceptions in the process or problems or issues and investigating those on an ongoing or continuous basis. So a lot of that is similar to the performance evaluation cycle we talked about in Chapter 9. And these variances, by definition, really are raising exceptions. So it fits nicely with that. Now, standards can provide benchmarks that promote economy and efficiency, so very much related to that point about management by exception. If we have these standards established, we can always be determining how we are performing relative to that standard, that ideal, in other words. Standards can simplify bookkeeping to some extent, and they really do support our responsibility accounting systems that we've been talking about earlier this semester. Again, as we spoke about with regards to these production managers, purchasing managers, and so on, if we have different standards for different things, so standards for prices, standards for usage or quantities, it helps us assign responsibility to those potential exceptions. Who's our first point of contact when something does trigger or pop up a variance? Now, there are some potential issues with standard costs. Variance reports are usually put together on a monthly or some kind of periodic basis otherwise, so the information might be outdated. In other words, timeliness is potentially an issue. Now, it's less of an issue in modern manufacturing and with big data and sort of continuous accounting, but still is a concern. Second, when we've hinted at this with some other things around budgeting, variances can't be used strictly to punish managers. So we have to make sure that we're using them to motivate improvement without strictly kind of using them to say, here's what you're doing wrong, and you may have some consequences for that. Now, labor variances that we've talked about, they assume that production process is labor-paced and that labor is strictly a variable cost with regard to activity. Those assumptions may not hold in a more automated environment, which is more and more common in modern manufacturing. So just something else for us to be aware of there. And just a few more considerations. First, just meeting standards may not be sufficient. So in a very competitive environment, we may need to continuously improve to survive. And our standards just kind of tell us, are we hitting this benchmark or this ideal? It might not tell us, are we doing enough to continue to be competitive in the marketplace? Now, separately, in some cases, favorable variances might be as bad or even worse than an unfavorable variance. One example that we hinted at with our Glacier Peak sample company here is with regards to materials, right? Maybe if we're purchasing low quality materials, we may have favorable materials price variances, but we may be producing inferior products, which might lead customers to never come back to us, right? That's very much a bad thing that's a consequence of this favorable variance. It's just one example too. And then finally, excessive emphasis on meeting standards might overshadow sort of the big picture or other important lower level objectives like maintaining and improving quality or ensuring that things are delivered on time or, as I alluded to just a minute ago, customer satisfaction. So we can't lose sight of the forest for the trees, as the saying goes. We want to make sure that our standards and any way that we're using standards to motivate and reward managers fits in line with our bigger picture objectives and goals as well. So that wraps up the second discussion video here for Chapter 10. Make sure you back up and review anything you need to. And as always, let me know if you have any questions.